Here is example 1 from lesson 59. A man wants to construct a box whose base length is twice the base width. The material to build the top and bottom is $9 per square meters, and the material to build the sides is $6 per square meters. If the man wants the box to have a volume of 70 cubic meters, determine the dimensions of the box that will minimize the cost of production. So there's a lot of information given. I'm going to start by making a sketch of the box that we're talking about here and label the sides, the height, and the length of the box. So we know that because the side length is twice that of the width, so we can call x and 2x, and the height h. And also note that the top and bottom, so this piece here, and also let's also put in the base. The bottom piece, these cost how much? $9 per square meters. And then the sides, they all cost $6 per square meters. Okay. The volume of the box must be 70 cubic centimeters. All right. So let's put this here. And we want to minimize the cost of production, which in a sense translates to minimize something that's related to the surface area of the box. Other ideas that we need to consider would be the domain and range of the variables that we have. Since we're dealing with dimensions, we know that x must be greater than 0. So is h, the height of the box. Okay, so we're ready to take a look at what kind of equations or relations we can find. Let's start by considering the volume of the box. We know that the volume of this box can be calculated by multiplying x, 2x, and h together. So that's 2x times h. Substituting 70, I have 2x squared times h. Just like what you have done in the investigation, it seems like if I isolate h to be 35 over x squared, this will give us a useful expression to substitute into our optimization equation. And since we know that this has to be greater than 0, height has to be greater than 0, it also implies that 35 over x squared needs to be greater than 0. Okay. So it looks like we are ready to come up with a function to represent the cost of the function. So let's call that C. The cost of the function comes from multiplying $9 per square meters of the top and bottom. So I have two of those faces, and each of those faces is 2x times x, so 2x squared. Plus two of the shorter sides, or the smaller sides, that comes from x times h, plus two other sides that has an area of 2x times h. Okay, so let's clean up this expression first. We have 9 times 2 times 2, so 36 x squared. We have got 2xh, 4xh, so that's 6xh, 6, 36 x and h. Let's write this cost function in terms of one single variable. So we're going to sub h equals to 35 over x squared and get c equals 36 x squared plus 36x times 35 over x squared. So now let's simplify that further. This is 36 x squared plus 36 times 35 is 1260 over x. That's cost. Now we are ready to do the key step in optimization using differentiation. Let's look for the derivative of c with respect to x. So what do we have here? 2x times 36, 72x. I have 1,260 x to the power of negative 1, so this will give me negative 1260 x squared in the bottom. All right. So we know that to find the minimum cost, the derivative is equal to 0. Let's solve this equation for x. I have 1260 over x squared equals 72x. X cubed is, if you cross multiply, x cubed is 1260 divided by 72. So we're taking the cube root of that. Using my calculator, this works out to roughly 2.60 meters if I round it to 3 significant figures. And then using this value, we can find the value of h using this formula that we have come up with previously. So for h, this is 35 divided by, if you use the original number on the calculator, but here I'm just going to write the rounded answer. This is approximately equal to 5.19 meters. Okay, so let's take a look at the question one more time. What do we need to answer? Determine the dimensions of the box that will minimize the cost of production. Okay, so we can say that therefore the box has dimensions 2.6 meters by twice of that, 5.2 meters, or if you kept the original number, it should be 5.19, I believe, and by 5.19 meters for the height. And that's it for this question.